The last big bit of quadratics that we are going to be looking at is something called the discriminant. I'm going to take a minute to remind you that to discriminate between things is to recognise a distinction or to differentiate. You'll know it in more of a negative context where we're talking about discrimination as in race, but that doesn't mean it always has to be so. To discriminate is to notice a difference. Now we are going to use the discriminant, which is the part under the square root, to determine how many roots our quadratic or parabola would have. We're going to have a look at the three different situations. Now, if we think about values in maths, we either have things that are less than 0, so b squared minus 4ac less than 0. We have things that are equal to 0, b squared minus 4ac equals 0. And we have numbers that are more than 0. So if you had to split up your values into key categories, you'd have less than 0, equals 0, more than 0. And I'm just going to split these off into 3 columns. If we turn our attention to this first category, b squared minus 4ac is less than 0. And we think about the effect this would have on our quadratic formula, which guarantees finding our roots. You're going to be taking the square root of a negative value. And if you've ever typed in the square root of a negative onto your calculator, what comes up is an error. Now this is really important because what this means is we theoretically have x equals minus b plus or minus an error over 2a. Now you are not going to get an answer out of this. So there are no real roots. No real roots. What does that look like? Well, remember, your parabola is always the same shape. Your roots are where you cross the x-axis. So if you don't have any real roots, all this means is that you are crossing, but at no point are you crossing that x-axis. Let's look at the second column. We've got b squared minus 4ac equals 0. So b squared minus 4ac equals 0. That means we have the square root of 0, which would be 0. Again, if we have a look at it in the formula, we have x equals minus b plus or minus 0 all over 2a. If you're adding or subtracting 0, that is essentially going to disappear, isn't it? And that leaves us with the fact that we always have two solutions here. We have two real, because they exist, and equal roots. Because you would still split this up into your plus and your minus, but because you're adding and subtracting 0, they're just going to be the same number. So we have two real and equal roots. Now, what does this look like? This is the rare situation where you touch the x-axis once, and once only. Okay? You touch it for the briefest of tiniest of milliseconds, and that is it. And this means you have two real and equal roots. The last situation we're going to look at is when b squared minus 4ac is greater than 0. And this is probably the most common situation you're going to interact with, particularly if you're using the quadratic formula. But this means you're taking the square root of a positive number, and that will give you a positive answer. Therefore, when you go to your formula, x equals minus b plus or minus over 2a, you're going to be adding and subtracting a value. And this is how you end up with two real and distinct roots. That's the word we like using here. Distinct means you can tell the difference between them in comparison to when they were real and equal, and both the roots were indistinguishable. Here, what would it look like? Well, that is your classic example where you are going through the x-axis at 2 points that are different values. So that might be -1 and 3, for example. We're now going to go through the examples from the notes, putting our values in and seeing how we can use the discriminant to determine the number and type of roots we have. First of all, we had an example which was x squared plus 4x plus 3. We identify A, B and C. So A equals 1, B equals 4, C equals 3. We copy the discriminant from the front of our test paper in the formula list and we substitute. So 4 squared minus 4 times 1 times 3. Simplify it down and you will get the answer 4. Now you have processed and calculated the value of the discriminant. What you need to do from here is write a sentence to show that you actually understand what that 4 means. So 4 is positive, which means we have 2 real and distinct roots. So the sentence you are going to write is, as b squared minus 4ac is more than 0, there are 2 real and distinct roots. Done. Let's have a look at the second example. So the second example was x squared plus 4x plus 4. Again, you go through a equals 1 because there's nothing in front of the x squared, b equals 4, c equals 4. You copy the discriminant from the front of your test paper and you substitute in. So 4 squared minus 4 times a times times c. 4 squared, 16, take away 16, and we get 0. And we think back, well, what does it mean if we have a discriminant of 0? It means we have 2 real and equal roots. So we write our sentence as b squared minus 4ac equals 0, there are 2 real and equal roots. Okay, last example we had in the notes was this one here. So we've got 2x squared plus 4x plus 4. A equals 2, B equals 4, C equals 4. Into the formula it goes. So 4 squared minus 4 times 2 times 4. So we have 16, take away 32, and we're getting an answer of minus 16. Now what happens when you take the square root of a negative number? It breaks. So we're never going to get 2 roots out of this. As a result, our sentence is, as b squared minus 4ac is less than 0, there is no real roots.